Everyone, welcome to the new video. So today we are again starting with the Terraform tutorial series and we are in day 10. So let's go. For day 10, we have remote state management. In remote state management, we are going to understand about storing state in AWS S3 Azure Storage or GCS, then the state locking with DynamoDB and backend configuration. So basically the goal for today is configuring remote backend for team collaboration. In day 9, because we have uh, discontinued the series for few days in between, so last video was covering day 9, which was on Terraform workspaces, that how we can manage multiple environments using Terraform workspaces, and how it is creating separate state file for each environment. So there is a separate state file maintained. So now for day 10, when we say remote state management, so why we need remote state management? Let's understand. So when we have a Terraform state TF state file which gets created and which actually keeps a check that whatever we have created actually and whatever is there in a real world, or whatever is there in our script, that is matching. So when every developer will have the Terraform TF state file locally stored, there are chances that whatever changes will get overwritten, and there will be no consistency, and changes that chances are that whatever we are creating, whatever we are destroying, it will make our infrastructure corrupt or not balanced. Because if somebody misses the uh, content of some other developer in this way, why we use version control system for storing our code and working on it, it is because of this only, so that the changes that other developer is doing, those changes are not missed, and everything is in sync. So to keep everything in sync, it's very important that we, instead of keeping the Terraform TF state file locally, we should have stored in a remote uh, place. Remote place is a centrally available space that every developer or user who is working can use it, and the consistency is maintained with remote place. Because when we are storing it in a common location, then the issue is that uh, uh, locking issue should be there. Because if two people are making changes on the same thing, then there are chances that one person changes will that there will be a lock kind of situation should be created, that the other person changes are also not uh, it's not like that both the person are making changes on the same thing, and there should be no discrepancies. So locking is there, that there will be a lock till the time other person make the change. uh, the another user won't be able to make the change. So locking is also required, because that's when because that is required, because there is a centrally localized Terraform TF state file that is being used. So for locking, we have DynamoDB created in AWS, which is most popular. It's like a reference data. So as we know that, in reference data, when we have studied about MySQL, there a key should be unique. Okay, and same key cannot be edited. If one person is working on the same key and the other person will be logged, and that person cannot make a change unless until the other person cannot will stop doing the changes on the same key. or the same row. So that's why this DynamoDB came into picture. For locking mechanism, we started using this DynamoDB. So what we use to keep our Terraform state file in a central place. The most popular services that we use is AWS S3. It's a bucket, storage bucket, where we can centrally store the Terraform state file and everybody can access it. Then in Azure, we have Azure storage account. This is also a storage account where you can centrally and store your Terraform state file, and you can um, you know access it. Then in Google, we have Google storage account. Sorry, we have Google's cloud storage. So again, it is a storage. So where why these storages are used, because we can maintain versioning also over here. If you want to roll back the changes, we have versioning enabled, so we can easily go to the older changes and see that if our Terraform TF state file gets corrupt anytime, we can get the changes of old Terraform state file. So this is how things will work. Um, uh, and then for locking, we will use DynamoDB. So I hope that storing state, why we are storing state in AWS S3 as or storage GCS, then why we are using state locking with DynamoDB. You would have understood that why we are doing it. Then how to configure it. So first of all, if you want to create the bucket, or the S3 bucket, or Azure storage account, or there should be Azure storage account created, okay, or S3 bucket created, or and DynamoDB table created. So once that is created, or we have already, you can create it using Terraform also. You will have to give AWS S3 the name of that bucket that you want to refer, the bucket name, and force destroy true. You can enable versioning. Similarly, you can create DynamoDB also by giving AWS Dynamo resource data. We have to give the DynamoDB table name, then the billing mode, the hash key lock ID, and the attributes of that table. Basically, the columns, the lock ID and type. Basically, the lock ID and type, it will be S. So type will be string. So in this way, once our table and everything is created, in our main.tf or in our provider.tf, where we are mentioning the provider, the plugin that we are going to use, there you need to mention you, stating the backend. So basically, if you are going to mention any, if you want to store your Terraform TF state file in remote state, you have to mention the name, the details of that storage account using backend. In provider.tf, if you don't have provider.tf, if you have everything in main.tf, you have to mention it in main.tf. You have to give like backend S3 and the bucket name that you are going to use, that will be getting created, and the key. Um, so this is the key, bucket key region in which it is going to be stored, the DynamoDB table, and then this is the path actually which is going to be stored, DynamoDB table, and then encrypt is true. You have to mention the DynamoDB table which is created. So let me duplicate it so that you can get more understanding. So if we see S3, and if we see my Terraform remote state demo bucket, so this we have got from like we can also mention it using outputs.tf. We have to give the value, so whatever the name will come, that name we have to, I would suggest, like, we should already have a S3 bucket created through an API, and then that name we can use over here. Similarly, DynamoDB table name too. So this is how, once this backend you have configured, your Terraform TF state file will go inside this, because this is how it will understand that our Terraform.tf state file should go in this path, and will be stored there. The connection and all should be provided, that how it will connect and everything, those credentials should be given. Similarly, in Azure, we have to give the storage account. These should be created. So in Azure, we have resource group name under which. So in AWS, we have region, and under region, we are creating any resource. Similarly, in Azure, we have resource group name under which we are going to create any resource. So it's like a namespace, you can say, isolation kind of thing from other resources. So again, we are going to give storage account name where it should be stored. And then similarly, we have to give about in Google, in GCS, how it should be stored. So this is how we are going to present, or store our Terraform state file in remote. So I hope you have understood about this topic, remote state management, and how you are going to configure it as a backend. So that's all. So that's all for today's video. I hope it's helpful. Please let me know your views in the comment section. Till then, take care. Bye.